So my name is Teja, and I am giving this presentation for my Automata theory project, which is Cky Parser, and my CW is ID is 5031953. And, before getting into the detailed structure of my project, I am going to execute each and every sentence in my project which related to the national park management using the C++ code. And I implemented a C++ code for my project to check whether the given sentence is a valid or invalid using the Chomsky normal form grammar. And I am using the online C++ compiler for my project. In my project, I have given a rule which says the right hand side, the left hand side of the rule is represented by S, and it indicates that the sentence, the start of the sentence, and the right hand side is represents a different way to expand the sentence S. So the first option is NPVP. It says that the sentence can be expanded into noun phrase followed by verb phrase, and the second one is X1. Here X1 is a non-terminal which is combined two non-terminals in it. So the sentence S can be expanded into X1 followed by verb phrase. The X1 is again followed by auxiliary followed by noun phrase and the verb, and the third one is the sentence S can be expanded into verb followed by noun phrase, and the same thing, it can be followed, the sentence can be expanded by X2 followed by PP. Here the X2 is a combination of two non-terminals, which is a verb and a verb followed by noun phrase, and the other one, the sentence S can be expanded by verb following the preposition phase, and also the same here it goes. The last one, the sentence S can be expanded into verb phrase followed by prepositional phase. The NP noun phrase can be expanded because the two non-terminals combine to give a one non-terminal. So let's discuss about the Chomsky normal form later, after the execution of my sentences. This is the rule that I give, and I derived I derived two non-terminals into a one non-terminal to execute my code. Let's run the code. And I have taken 15 valid sentences and 6 invalid sentences for my project, and those are this 15 are the valid sentences which says my code, those are valid. First sentence, explore the beauty of wildlife. Explore the beauty of wildlife. The sentence is valid. Let's go to the second sentence. Regulations ensure safety. Regulations ensure safety. Since all these sentences are following the grammar that I gave in the code, the third sentence is enjoy the nature activities. Sentence is valid. And the fourth sentence is protect the ecosystem. It's a valid. Ask the ranger for directions. Valid. Search for the parks in Texas. Sentence is valid. Go to the go to the park. So valid, search all parks. Sentence is valid. Look the parks on websites. Look the parks on websites. So for every sentence, I have given a command to go for the another sentence or to exit from the code. So I'm a bit confused here. So I'm sorry. The sentence is valid. So I'm quitting this program at sentence number after the execution of sentence number 9. Exit. So let's run the code again and start from the sentence 10. Search all parks. Sentence is valid. And the next sentence, let's continue with the sentence number 10. Search the parks by fair. Sentence is valid. Search the rangers by name. Sentence is valid. Next sentence, search the parks by number. Sentence is valid. Search the park timings. Sentence is valid. Search the park by destination. Sentence is valid. Arrange the park tickets. So sentence is valid. Let's quit the program and run again to check any other sentences apart from this 15. All are invalid because those are not following the grammar that I have given in the code. So let's go with the invalid sentences. Can I book with park? Sentence is invalid. They are rangers. Sentence is invalid. Anyone can check all parks. Sentence is invalid. Ask the ranger for help. Sentence is invalid. Does rangers help? Sentence is invalid. Camping is allowed for visitors. Sentence is invalid. Let's exit from the code and let's go for the presentation. So Dr. Sangsu here have given all my sentences execution, 15 valid sentences and 6 invalid sentences. And I'm closing my C++ online compiler because I have given the parser execution for each and every sentences that I have present in my project. Table of contents that I have designed for my project is introduction of Cky parsing and the brief history, how it is evolved from day 1 to now, and my project objective, and the languages that we are using in this project is a context-free grammar and the Chomsky normal form, and the valid and invalid sentences those are the sentences that I gave. Those are the sentences that I executed just now, and for each and every the valid and invalid sentences I have derived a table using the CNF grammar to all those grammar combined to give a single result that the sentence, the left hand side sentence S should start and end with, and the terminals and non-terminals, all of those things put in those code to say that the sentence is a valid or not, and the conclusion. Let's jump into the introduction of Cky parsing. CKY parsing. What is CKY parsing? CKY parsing, also known as Cky Younger parsing, is a parsing algorithm used in natural language processing and computational linguistics to analyze the structure of a sentence based on a given grammar. It is a bottom up parsing algorithm that determines the syntactic structure of a sentence using context free grammars, CFGs. The CKY parsing algorithm works by building a parsing table, also known as a chart, which stores partial parse trees and their corresponding non terminal symbols. The algorithm proceeds in a series of steps starting with the individual words from the input sentence. It considers all possible ways to combine adjacent words into a larger constituents according to the production rules of the CFG. By iteratively, by iteratively applying these rules and combining constituents, the algorithm builds a parse tree for the entire sentence. CKY parsing is particularly useful for languages with complex and ambiguous syntactic structures. Overall, CKY parsing is a powerful technique for syntactic analysis and understanding the structural relationships with the sentence, which forms the basis for many natural language processing tasks such as machine translation, information extraction, and question answering systems. Especially, if we consider that the sentence has 6 words, it should have one uh, n minus 1 boxes in the charts, and for each and every box from 0, 1, 2, 3 words in the sentences, it takes the one sentence, one word in the first, and the two words in the next, and it goes on by iteratively. Brief history. The CKY Kasami Younger parsing algorithm was introduced by John Cky Kasami and Daniel Younger in the late 1960s. It is a parsing algorithm used to analyze the structure of sentences based on a given context-free grammar, CFG. The development of CKY parsing was motivated by the need for efficient parsing algorithms that could handle the increasingly complex and ambiguous nature of natural languages. Over the years, CKY parsing has been further refined and optimized. Various extensions and modifications have been proposed to enhance its performance and handle specific linguistic phenomena. Today, CKY parsing continues to be a fundamental technique in natural language processing and computational linguistics. It serves as the basis for sorry. It serves as the basis for many parsing algorithms and plays a crucial role in tasks such as syntactic analysis, grammar checking, machine translation, and information execution. Project objective. The next topic is in my project is what is the objective of my project? The objective of my project is that the domain of the project is that how to implement a application in the national park management. The goal is to create a system that allows users to search for and access information about national parks using criteria like park name, location, or available activities. CFG may be used to create statements regarding national park resources, activities, search techniques, and other park related operations. The grammatical standards can be modified to the park administration's individual needs and lexicon. Some of the regulations may need not be changed. After constructing CFG, the CKY parsing technique may be used to build the CKY tables for each of the generated national park related terms. The CKY table will assist in establishing the validity or invalidity of sentences based on recognized grammatical rules and lexicons. This research can help to design strong national park administration apps and systems capable of managing user inquiries, information retrieval, and a variety of park-related activities. The project will also feature a C++ code that collects input to the parser and output whether the sentence accepted is valid or not. The next topic is a context-free grammar, CFG. CFG. Sorry about that. A context-free grammar called a CFG is a collection of three things. An alphabet Y of letters called terminals. What is a terminal? Terminal is a word that cannot be replaced by any other word, like nouns. Nouns cannot be replaced by any other word in English, in the grammar. an alphabet Y of letters called terminals from which we are going to make strings that will be the words language. A set of symbols called non-terminals. What is non-terminal? Non-terminal is a word that can be replaced by other words. Like we can paraphrase a sentence. Like we can paraphrase a sentence like 3, 4, or maybe some many times, but we cannot change the few words in those sentences like nouns and the verbs, especially the nouns, which are called as terminals, and the words that can be replaced with any other words, those are called non-terminals, one of which is called the symbol as standing for start here. A finite set of productions of the form one non-terminal is should be replaced by a finite string of terminals and or non-terminals. Context-free grammar is a formal grammar framework used to describe the syntax or structure of a language. It consists of a set of production rules that specify how to generate valid sentences in a language. A CFG is composed of terminal symbols, non-terminal symbols, a start symbol, and production symbols. The grammar that I have using in this project, CFG, here the first statement, yes. This rule states that the sentence yes can consist of a noun phrase followed by a verb phrase. It represents a basic sentence structure. This sentence here, this represents this rule allows for the presence of an auxiliary verb in the sentence in addition to the noun phrase and the verb phrase. It accounts for the sentence with auxiliary verbs like is, as, etc. This rule here represents sentences where the subject is omitted and only a verb phrase VP is present. It covers cases like imperative sentences or sentences where the subject is implied. And this rule indicates that a noun phrase can consist of a pronoun which represents a word like he, she, it. And this rule specifies that a noun phrase can consist of a determiner, which we call it as a det, followed by a. This rule specifies that a noun phrase can be a proper noun representing names of specific people, places, or strings. This rule states that a noun phrase can consist of a determiner followed by a nominal. This rule. Nominal. This rule indicates that a nominal can be a single noun, and nominal can be a combination of nominal followed by noun. And this rule here, it states that the nominal can be a nominal followed by a preposition phrase, modifies the noun. This rule states that the verb phrase can consist of single verb, and this rule here allows the inclusion of a noun phrase after a verb, creating verb phrases like read a book, eat lunch, etc. This here, it indicates this rule extends to the verb phrase by including a prepositional phrase after the noun phrase. It enables construction like give a gift to her when the prepositional phrase modifies the verb. And this rule here allows for the addition of a prepositional phrase directly after the verb, creating verb phrases like run in the park, play with friends, etc. This rule enables the extension of a verb phrase by adding a prepositional phrase to it. It covers cases where multiple prepositional phrases modify the same verb, like jump over the fence in the garden, and prepositional NP. This rule indicates that the prepositional phrase consists of a preposition followed by a noun phrase, creating phrases like in the house, on the table, etc. And the grammar is continued in the next page. Lexicons. These lexicons can be derived by the sentences that I have been used in the project, which are those are the 15 valid sentences and 6 invalid sentences. And let's get into the next topic, Chomsky normal form. Chomsky normal form is a specific form of CFG that imposes certain restrictions on the production rules in CNF. Each production rule must have one of the two forms. either a non-terminal symbol generating two non-terminals or non-terminal symbol generating a terminal symbol where A, B and C are non-terminal symbols. CNF. Before the CFG should be converted into CNF by replacing the start symbol yes in the right hand side with another non-terminal and creating new production. That is the step 1, and step 2 is removing all the null productions and unit productions and useless productions from the CFG to CNF. We can call the step 2 as a simplification of CFG. And the third rule, replacing terminals on the right hand side with non-terminals and creating new productions. And the step 4, replacing number of non-terminals on RHS by creating new production. That is either a non-terminal symbol generating two non-terminals. The purpose of transforming a CFG into CNF is to simplify the grammar. So we can say that the conversion of CFG to CNF is the simplification of grammar. CNF has desirable properties that allow for efficient parsing techniques such as the CYK algorithm, which operates on CNF grammar. The CNF conversion involves rewriting the original grammar by introducing the new non-terminal symbols and intermediate productions. The new non-terminal symbols that I have using in my code in my project is x1 and x2. This process preserves the language generated by the original CFG while ensuring that all production rules adhere to the CNF constraints. This grammar that I have used in my project is there is a note that the first rule is the same as it is in the CFG. Here I have created a new non-terminal x1. So here this rule allows it says that the x1 is an introduction of an auxiliary phrase before the verb phrase, and the x1 is divided into x1 can be expanded into auxiliary phrase followed by noun phrase. The S sentence yes can be expanded into verb phrase, verb following the noun phrase. And the other rule, this rule allows for the introduction of another phrase x2 before a prepositional phrase pp in a sentence. x2 is a verb NP. This rule specifies that the phrase x2 can consist of a verb followed by a noun phrase. And here the S, this rule indicates that the sentence S can consist of a verb followed by a prepositional phrase, and the next one, it indicates the extension of a verb phrase by adding a prepositional phrase to it. These are all the noun phrase, they and I. This rule represents pronouns they and I that can be used as noun phrases. And the second one, this rule allows for the inclusion of a prepositional phrase, that is a prepositional nominal within a noun phrase. This rule states that a noun phrase can consist of a determiner followed by the noun. Here, the nominal. This rule indicates that a nominal can consist of a single noun, and again the nominal is a combination of multiple nouns to form a nominal. And the third one, this one is an extension of a nominal by adding a prepositional phrase, and the last one is extension of a nominal by adding a prepositional phrase to it. The last one enables the addition of a preposition to a nominal. These production rules provided a structured framework for generating and analyzing sentences in the given Chomsky normal form. By applying these rules and combining the appropriate components, we can generate valid sentences with different structures and combination of noun phrases, verb phrases, prepositional phrases, and more. and all the lexicons that I have used in the CFG. These are the lexicons which I have derived, I have taken from the sentences. Those are the 15 valid sentences. Those are not at all changed. There is this lexicon should not change in the CNF grammar. That is, the lexicons is the same as in the CFG and as in the CNF. The lexicons remain unchanged. The valid and invalid sentences that I have used in the project. These are the valid and invalid sentences that I have used in my project, and I have given the execution of the parser execution for each and every sentences in the starting of my project, in the starting of my presentation. Cky derivation tables. So I have to take this derivation table from my project document. Let's explain one derivation here. This sentence: explore the beauty of wildlife. So we can say that explore is a verb, the is a determiner, beauty is a noun, of is a preposition, wildlife is a noun. So as I stated in the CNF grammar, this sentence follow all the rules that I indicated I have implemented in the code. Okay. Let's get into the detailed explanation how I derived this table. So the first word explore is a verb. So this is the table 0, 1, 0, 2, 0, 3, and I have given the names for each boxes in the derivation table. SVP verb. This step indicates that the word at this position 0 to 1 in the input sentence can be derived as a non-terminal symbols SVP verb, and 1 to. This step indicates that the word at position 1 2 in the input sentence can be derived as a non-terminal symbol preposition, and 0 2. 0 2 is a combination of 0 1, 1 2, and here SVP verb and preposition combines to give a new non-terminal X. This step combines the previously derived non-terminal symbols from 0 1 SVP verb and from 1 2 preposition to form a new terminal symbol X. 2 3 is a nominal noun. This step indicates that the word at position 2 3 in the input sentence can be derived as a non-terminal symbols nominal noun, and it is derived from 1 3. 1 3 can be taken from 1 2 and 2 3. Gives a 1 2 and 2 3 gives a preposition nominal NP. This step combines the previously derived non-terminal symbols 1 2, which is a preposition, and 2 3, which is a nominal noun, to form a new non-terminal symbol NP. Now 0 3. It is a combination of 0 1, 1 3, 0 2, 2 3, which is a SVP verb NP to form VPSX2. This step combines the previously derived non-terminal symbols 0 1 SVP verb and 1 3 and 2 3 preposition nominal, as well as 0 2 X and 2 3 nominal noun to form a new non-terminal symbol VPS and X2. The subsequent steps follow a similar pattern of combining non-terminal symbols and terminal symbols until the complete sentence is derived. Each step involves applying the production rules of the grammar to generate new non-terminal symbols and eventually constructing the parse tree for the sentence. The final step 05 is a S sentence VP verb phrase X2 is going to give VPS X2. Shows the derivation of the entire sentence using the previously derived non-terminal symbols VPS and X2 as well as terminal symbol NP. Overall, the derivation process demonstrates how the CKY parsing algorithm systematically builds the parse tree for a sentence by combining smaller constituents according to the rules of the grammar. These rules of the grammar that I have taken from these sentences, and I have implemented a CFG grammar, and I have converted the CFG to CNF grammar. Uh, CNF grammar. For each and every sentence, I have a derivation table, and I have written how I derived the table from step 1 to the final step. And not only the one sentence in this, from this I can take the two sentences, like explore the beauty is one sentence which we can format 2 3, and the second sentence is enjoy the beauty of wildlife, which we can format 0 5. The valid sentences from the above derivation table is explore the beauty, which can come from S0, 3, and the other sentence is explore the beauty of wildlife, which can come from S0, 5. And for all the 15 valid sentences and 6 invalid sentences, I have the derivation tables, and I have derived those sentences using the grammar from step 1 to final step. Here I conclude my project. In the conclusion, I can say that Cky parsing is a parsing algorithm used to analyze the structure of sentences based on a given context-free grammar. It employs dynamic programming techniques to efficiently construct parse trees for sentences. CFG is a formal grammar that describes the syntactic structure of a language in terms of set of production rules. It consists of set of terminal symbols, quotes or lexical items, and non-terminal symbols, syntactic categories, as well as set of production rules that specify how these symbols can be combined to form sentences. Chomsky normal form (CNF) is a specific form of CFG in which all production rules have one of the two forms, either a non-terminal symbol producing two non-terminals or a non-terminal symbol producing a terminal. CNF simplifies the parsing process and enables more efficient algorithms like Cky parsing. It also facilitates mathematical analysis and theoretical study of formal languages. Overall, the Cky parsing, CFG, and CNF are fundamental concepts in natural language processing, NLP, and computational linguistics. They are used for syntactic analysis, parsing, grammar checking, machine translation, and other NLP tasks. By employing these techniques, we can understand the structure of sentences and extract meaningful information from natural language text. Thank you very much, Dr. Sangsu, for giving this opportunity. Here I concluded my presentation. Thank you very much.